All right, so today we're going to talk about writing functions, or what function notation is more specifically. So um, up until now, you've always had equations where it's y equals, or there's just one variable. So function notation, we read this out loud as f of x. So I'm going to add that up here. F of x is what I say out loud. But this is a function of x, is another name for y. So if you have y equals 3x plus 4, we can rename that as f of x equals 3x plus 4. So in functions, we like to use function notation because it really is clear for us what we're inputting and what's coming out, and what is our x and what is our y value. So here, y or f of x is the output. That's what our result is. X is always the input, what we're plugging in. Also, x we will sometimes call independent because it's really the one in control. Y or f of x is dependent because it depends on what you plug in for x. So let's look at some examples here. For functions, we're not going to use y. It says they're interchangeable, but we really want you to get used to this new notation, so we're only going to use f of x for this unit, so that you can get used to the notation. So it says evaluate f of x equal to negative 4x plus 7 when x equals 2. So we are going to replace x with 2. And now we're going to simplify the right-hand side. So negative 4 times 2 is negative 8. And negative 8 plus 7 is negative 1. So this is an input of 2 and an output of negative 1. This is not the same thing as 2f, where we'd have to divide it to finish solving. This is our function notation. So this is an input of 2 and output of negative 1. It makes it very clear what we plugged in and what we got out. So let's do another example. I'm going to replace x with 6 for this one. So 1/2 times 6 is 3. Or half of 6 is 3, if you've never heard it that way before. Half of 6 is 3. 3 minus 4 is negative 1. So again, at this point we are finished. This is saying that we plugged in 6, we got out negative 1. This is not the same as 6f, where we would divide. Input of 6, output of negative 1. So now we're going to work backwards. It says find x when h of x is negative 7. So we're taking this negative 7 and plugging it in for h of x. And they don't have to be f. We use f a lot for function, but they can be any letter. So that's what this h of x is showing you. It doesn't have to be an f of x. And now I'm going to work backwards. So I'm going to add 5 to both sides. And then to get rid of a fraction, you multiply by the reciprocal. So you get x is equal to negative 3. Now I want to put that back in my function notation. So I'm going to say h of 3 equals negative 7. My input is 3, my output is negative 7. All right, so we'll do another one of those. Here we have h of x is negative 2. So I'm going to have negative 2 equals 4x plus 2. And then I'm going to solve for x. So I'm going to subtract 2 from both sides. And then divide by 4 on both sides. So this is my input. I have an input of negative 1 and an output of negative 2. So that's how we would write it in our function notation. So we're going to graph these. We're going to use our input-output function, for lack of a better word, to graph this line. So for x, I can choose anything I want. If there is no fraction, the easiest set of numbers to choose are from negative 2 up to positive 2. Really, you only have to have 2 points to make a line. For practice, we're going to go ahead and do 5 because we're really trying to work on this skill. It's brand new to us, so I want it to do more than 2. But if I plug in -2, 3 times -2 is -6. -6 minus 2 is -8. If I plug in 1, I get 3 times -1 is -3. -3 minus 2 is -5. If I plug in 0, 3 times 0 is 0. 0 minus 2 is -2. If I plug in 1, 3 times 1 is 3. 3 minus 2 is 1. And if I plug in 2, 3 times 2 is 6. 6 minus 2 is 4. All right, so now I've generated this table of points that I can plot on my graph. If I connect those, because we're saying that these are linear functions, they are lines, I'm going to go ahead and connect those. That would be my picture. Now let's go ahead and do an example where there's a fraction, because that's a little bit different. So in this case, I used 1/2. So instead of counting by ones, like here I went up by 1 each time, I'm going to want to go up by my denominator. So on this one, I'm going to want to go up by 2's, because that'll give me nice whole number answers. If I go up by ones, I'm going to have some fractions in my answer, which is not terrible, but they're hard to plot. So I'm going to go from -4 up to +4, where I'm counting by 2's for my points on this one. Half of -4 is -2. -2 plus 3 is 1. Half of -2 is -1. -1 plus 3 is 2. If I plug in 0, 1/2 times 0 is 0. 0 plus 3 is 3. If I plug in 2, 1/2 times 2 is 1. 1 plus 3 is 4. And then half of 4 is 2. 2 plus 3 is 5. So now I can plot those. 2, 4, 4, 5. And if you connect them, that'll be a nice straight line. If it's not a straight line, then you made an error when you were plugging in. All right, that's the end of our notes for today. You do have a big ideas assignment to work on.